Hi friends, in this video I'm going to show you guys how Pascal triangle was derived, and it was derived from two expressions, from a binomial expression and from the coefficients of each terms that are present in the binomial expression. Now suppose you are given an expression of, let's say you are given a plus b all raised to power 0, right? So this is a binomial expression, right? And we know that according to law of indices, anything raised to power 0 is actually equals to what? 1. Exactly. So here the expression, this expression is equal to 1, right? So here I'm going to have 1 at this center here. So now let's say I have another expression that's a plus b all raised to power 1. We all know that a plus b all raised to power 1 is the same thing as writing a plus b, right? So if you look at this, the power of of each times here is actually 1, right? And their coefficient is taken to be what? 1 and 1. So basically, as far as Pascal triangle is concerned, I'll be using an expression to derive a Pascal triangle using the coefficients of each terms that are present in the binomial expression. Now look at this. This is a binomial expression, and the coefficient of each terms a and b that are present in the this binomial expression is actually 1 and 1. So in this case, I can simply have 1 here and also 1 here. Now let's say I'm having another expression which is a plus b raised power of 2. This is also equal to, this a plus b raised power of 2, I can simply have it as a plus b and also what? A plus b. So by the time I expand this expression, what am I going to have? I'm going to have this what? That's a squared plus 2ab, right? Then plus b squared. Now look at this very well. You look at this the coefficient of each term here, we have 1, 2, and 1. So basically, I can simply have this was 1, 2, 1. So then, what if we have expression of a plus b raised power of 3? Now listen very well. We look at this case, we have 1 here, right? Then out of this side, we have 1. 1, we put the 1 here, and also we also put the 1 here, because we have two terms in this binomial expression. Now let's look at this. If I just bring this one down here, I'm having 1 here, right? Then 1 plus 1 is going to give me what? 2. Then I'm going to bring what? This down back. Now the next thing, I'm going to bring this one here. In this case, I'm going to bring this one here like this, right? Then I will go again. Then this, I'm going to add these two values together. That's 1 plus 2. That's going to give me what? That's 3. Then followed by 2 plus 1. That's actually what? That's 3, exactly. Then after that, then I'm going to bring this one down. So it shows us if you expand this a plus b raised to power 3, if you expand it, you're going to have this as the coefficient. Now what if you have a plus b raised to power 4? A plus b raised to power 4, since the power here is actually 4, then the coefficient is going to be, I'm going to bring this one down here, right? Then followed by 1 plus 3, that's going to give me what? 4. Followed by 3 plus 3, that's going to give me 6. Then 3 plus 1, that's going to give me what? 4. Then I'm going to bring this one down. So these are the coefficient of what? Of each term that are present in this expression. So by the time you expand this expression, you are going to have the coefficient of what? 1, 4, 6, 4, 1. Then let's say you are given a plus b raised to power of 5. Now a plus b raised to power of 5, I'm going to bring this one down, right? Then followed by 1 plus 4, that's actually 5, right? Followed by 4 plus 6, that's going to give me 10, right? Then followed by 6 plus 4, that's actually what? 10. Then followed by 4 plus 1, that's going to be what? 5. Then followed by what? 1. Then after that, what I'm going to do is that I'm going to, let's say I have another one which is a plus b raised to power what? Of 6. So in this case, I'm going to bring the 1 down, right? This one here, I'll bring it down. Then followed by 1 plus 5, that's actually what? 6. 5 plus 10, that's actually what? 15. 10 plus 10, that's going to give me what? 20. Then 10 plus 5, that's going to give me what? That's 15. Then 5 plus 1, that's 6. Then I'm going to bring this one down. So that's how Pascal triangle was derived. So Pascal triangle was derived from two expressions. The first one is the binomial expression itself and the coefficients of each time that are present in the binomial expression. So let me just call this binomial, right? If I simply call this binomial, then I'm going to call this what? Coefficients. Coefficients of what? Of each terms that are present what? In the binomial expression. Now let's solve some questions using Pascal triangle. Suppose we are asked to expand an expression of a minus x raised to power of 4 we are asked to use Pascal triangle to expand this binomial expansion. So first thing is that if you look at all the binomial here, all the binomials here, the sign is actually plus. It's actually addition sign, but here I'm having minus. That means I need to factorize this minus so that I can rewrite this expression as a plus into brackets minus x, then all raised to power 4. Exactly. So now the next thing I'm going to do is that the power is 4. Then if you look at this very well, the power of 4, this is actually the coefficients I'm going to use. These are the coefficients of each time that are present in what, in an expression raised to power 4. So this is what I'm going to use. So here I'm going to have 1, 4, 6, 4, 1. Exactly. So what I'm going to do now is that the first time that I'm having is a, then I'm going to raise it to the power of what, of 4. Then here I'm going to have a raised to the power of what, of 4. Exactly. Then the next time, whenever I raise the power of a raised to the power of 4, then the power of minus x, I'm going to raise to the power of 0. That's actually 1. Exactly. So there's no need for me to write it here. Then followed, I'm going to I'm going to decrease the power of a by 1. That is, I'm going to subtract 1. Here I'm going to have a raised to the power of 3. If a is raised to the power of 3 here, then minus x must be raised to the power of 1. Then I'm going to have this word minus x here. Right? Then followed by, here I'm going to have a raised to the power of 2. Then minus x will be what? Raised to the power of 2. Exactly. Then followed by this 4 here, I'm going to have a, then I'm going to have minus x raised to the power of 3. Then followed by what? Here I'm going to have the power of x equals what? 0. Then I'm going to have minus x raised to the power of 4. So if you take note of this, if you take a look at this very well, as the power of a increases, the power of what? Of minus x decreases. As the power of a decreases, the power of minus x increases. Exactly. So here, if I should simplify this expression further, I'm going to have this word a raised to the power of 4. Then this is going to give me 4. Then I'm having what? A raised to the power of 3. Look, if you look at this area, I'm having minus x here. That means this is going to be minus a. Then I'm going to have x. Then I'm also have minus x squared. That's going to be what? Plus x squared, right? Then I'm going to have this word plus 6a squared s squared. Then followed by this minus x squared, right? Minus x raised to the power of 3 is going to give me what? Minus x raised to the power of 3. Exactly. Then I'm going to have this word minus 4a x raised to the power of 3. Then here minus x raised to the power of 4 is going to be what? Plus x raised to the power of 4. Then here I'm going to have what? Plus x raised to the power of 4, because anything is power 0 is actually what? You look at this expression very well. So that's the expression. This is the expansion of this binomial expression. But one thing I want you guys to understand here is that as the power of a increases, this is the power of a, I have it to raise power of 4 here. As it decreases, then the power of x will start to increase. Here I'm having minus x is power of 0 here. Then here I'm having it to what? 1. I'm having it to be 2 here. I'm having it to be 3 here and 4 here. Here I'm having the power of a raised power, the power of a to what? 0 here. But followed, I'm having it to what? To be 1 here. I'm having it to be 2 here, 3 here, and 4 here. So that's just it. Just so that Pascal triangle was used to express all the coefficients of a terms that are present in a binomial expression. Now look at this. Here I'm going to have 1, then 4, 6, 4, 1. So that's just it. Exactly. Which is this. So that's it. So if you enjoyed this video, please do well to click on the subscription button and don't forget to click on the notification button as well. Thanks for watching.